Hello embedded system lovers, let's walk you through how to build your first IoT project using the ESP32 development board. We have the ESP32 and we have our red LED and we have a ohm resistor and jumper wires. So we first connect the red LED to our board this way. Then we connect the 100 ohm resistor to our board, and this is the cathode on the LED. Now this goes to the anode from the resistor. So we're connecting the cathode to the ground and this to any digital pin. So for now we're gonna pick D5. So our connection is set. So we're now going to go write the code. Okay, so we're about to write the firmware for our hardware, and to do that we're first going to include the required libraries that we need to make this work. And the two libraries that we need is the Wi-Fi library and the ESPAsyncWebServer library. These two libraries help us facilitate communication with the ESP32. So the ESPAsyncWebServer library helps us create an asynchronous web server, a simple asynchronous web server on our ESP32 that can intercept incoming HTTP requests and handle them to do the required tasks. Then we also need to define the pin which our LED is connected to, and we're going to use that in our code. So we're defining it as LED pin and it is connected to pin 5 in our case. So here's the complete code. So all you need to do is to change the SSID parameter or SSID variable to the name or SSID of your Wi-Fi. Likewise, the password, you put in the password. So on boot, or once the device comes on or the ESP comes on, it tries to connect to these particular Wi-Fi credentials. So we're going to go ahead and compile this code to see if there are no errors. And yes, the code compiled successfully. So we're going to go ahead and upload the code. So we check, okay, so my board is connected to the right ports. So we're uploading right now. So the Arduino software tries to compile the code again before uploading. Okay, so it's done compiling, about to upload. So it's uploading right now. And yes, it's complete. So we're gonna go ahead and test the code to test our routes and see how they work. Okay, so we're going to clear this verbose output. So yes, you can see our board is connected right now after resetting it. So this is the IP address that was given to it after connecting to the Wi-Fi ES diary. So this IP address is what we want to use to test our routes. So the browser is what we use to send HTTP requests. So first I connect to the Wi-Fi. I have to be on the same network with the same Wi-Fi ES diary. So in the browser, I'm going to type in the IP address then slash on, that is on route. So that basically calls on route, and then you can see yes, our LED is turned on. So the route handler on the ESPAsyncWebServer handled it correctly. So I'm going to try to turn it off right now too. Off, and our LED is off. So these are two simple routes that can turn on and off the LED. Turn it on again and it's on. So I'm going to try to create a simple page that let us do this without having to be typing on and off on the browser tab, since we don't always have to be using such browser of the browser. So I went to ChatGPT.com. So I want ChatGPT to generate a simple web page for me with two buttons I can use to turn the light, and it gave it a simple prompt. This prompt basically lets it generate this page for me. So it generates the full HTML code. Now, HTML codes are understood by browsers. They are executed by browsers, and that is what displays any single page you see whenever you visit any website. So you can do it at any time. You can generate to your own taste and your look and feel. I want to copy the code and create a HTML file so that I can paste the code to it and test to see what it looks like before we go ahead and implement it in our code. So I call it page.html. So the next thing we have to do now is to edit the content of this file, because HTML files are by default opened by browsers. So we need to edit it with the text editor before you can be able to run it. So this is the basic content inside, so I'm going to clear it and replace with what I got from ChatGPT. So I'm going to save this, and after saving, I'm going to go ahead and try to view the code. And yes, this is what it looks like. ESP32 LED control with my two buttons on and off. So let me show you what it does in the background. So this is me inspecting the behavior of it. So the console, you can see every single time I click the on and off button, it tries to send the same request, the on and off request we were sending earlier. So we're going to implement this in our code. To do that, we have to create a variable that holds this code in our Arduino code, our ESP32 code. So we create as a variable. So in this case, I call it index HTML. And I paste the code. So this is the code entirely. It's a string basically. Yes. So the full code is going to be in the description below, so you can always access it and use it to program your own board and test. Okay, so since we have our on and off routes on the async web server, now we have to create a new route, and this route is going to be intercepted by slash. So basically that is a route that gets visited every single time you visit. That is like the home page basically. So we created the it's going to be a get request too as well, and it's going to basically call the content of the variable index HTML and serve it every single time we call that slash route. Yes, so basically with that we can now compile our code and test. Okay, code is compiled successfully. Now we're gonna upload the code. So you see compiling here, and now we are uploading the code right now. And yes, we're done. So let us test the code and see how it works. So I'm going to reset the board, and boom, we are connected. So this is the IP address, so the same as IP address as before, although it changes, so you have to always get the right IP address all the time. So you copy the IP address, and we're going to go to our browser. So before we use the browser, we have to make sure that we connect to the network. So I'm connecting to ES Diary. As we connected, what I do now is I paste the IP address. So this time around, I'm not putting any slash on or off, just calling this IP address. So when you just call the IP address, particularly, it just sends the slash by default. And we remember we have already created something that intercepts that. So you can see our dashboard is here served correctly. So when I click the on or the off button, the route handler handles. So you can see the LED is turned on after clicking the on button. So there's a status bar there that tells us what happened last. So clicking the off button, you can see LED turned off, and yes, you can see our LED is turned off. On, LED is turned on, and off, LED is turned off. Isn't that beautiful? So yeah, let me show you from the console what it's doing. So you can see whenever I press on, it sends a request called on. So there's no response because we didn't put a particular response. So but if you check the header, you can see that it responds to 200. Okay, so the 200 that is being returned from the code basically means okay, so everything went well. That's what it means. So you can see the IP address there, HTTP 192 this and /off. When you press on and you check that particular request, you can see it. HTTP going, and you can see the IP address, then the particular on route. So basically every single time you press any of those buttons, that's the particular request that is sent, and the ESP server automatically handles it. And so yes, our code is working well. Thank you. Don't forget to like and subscribe for more embedded systems.
Did you enjoy this video? If you did, smash the subscribe button, like, just give me a thumbs up, and drop your comments about the video and the next project you would want me to upload in this channel. And see you in my next video. Thank you for watching, and bye bye.